So as you can see by the look of this sheet, it didn't load correctly into this video, but I'll give you just a quick overview. Page 1, with all of the motion graphs that are overlaid here. You basically need to know the difference between a distance time graph, a dt graph, which the slope is velocity, and a velocity time graph in which the slope is acceleration. That's what all those graphs are about, so you should go back to your notes and take a look at those. The next section is all about free fall. And for free fall, like number 9, a rock is dropped off a cliff. What is its initial speed? Well, its initial speed is 0 because it's not moving yet. And then if it takes 5 seconds to hit the ground, how high is the cliff? You would use, hang on a second. Y is 1/2 gt squared, and plug in 5, so you'd get 1/2 of 9.8 times 5 squared to get your height for number 10 there. The next part is all about projectiles. And projectiles, the basics of that, all of the questions are going to be about either how far away something gets, which is the range, how high off the ground it gets, which is the height, or questions about, the angle and how that affects how fast it's going in either the X or Y direction. So as your angle goes from 45 degrees to a higher angle, as you're going that way, your velocity in the Y direction gets larger. And as your angle goes from 45 degrees to a smaller angle as it moves down, your Vx gets larger. More of your speed is coming from the X direction. So over here, more of your speed is in the Y direction. Over here, more of your speed is in the X direction. And of course, to get the maximum range, you're going to launch something at 45 degrees. To find the time in the air for a projectile, to find the time to the top, you're going to use Vy over g, and total time, you would just multiply that by 2. Vy is going to be v sine theta, and Vx is going to be v cosine theta. Most of those questions are going to be pretty conceptual on projectiles. For example, on your review sheet for number 13, when it says which of the projectiles will have the longest hang time, that means which one will be in the air the longest, and it would be the one with the largest angle. So for number 13, the answer is 75 degrees because the Vy is the largest out of the numbers on that chart, which means that your time in the air is going to be the largest number for that as well. And then it says which projectile has the largest horizontal component of velocity. The answer to that one, number 14, would be A, which is 15 degrees, because your Vx is going to be the largest. All of your speed is coming from the X direction, which means its time in the air is going to be short, but it'll be moving fastest along the X. In the forces section, for number 17, for example, it says a 10 kilogram block is dragged across the floor. basically what you need to know is if that you have a 10 kilogram block, that its weight is going to be mass times gravity, which would be, I'll just use 10 for gravity in this case, so that'd be 100 newtons, which means the normal force would also be 100 newtons. And if you're going to calculate the force due to static friction, mu force normal, that would be 0.4, which is given, times 100. So you would end up with an answer of 40 newtons for the frictional force there. That's how much force you would need to pull it. For number 21 on momentum, it's talking about how impulse is equal to a change in momentum. Remember that momentum is mass times velocity, and that impulse is force times time. So you can set those two things equal to each other and say that impulse is equal to mass times a change in velocity, which is mass times velocity final minus velocity initial. That'd be a change in your velocity. So if we're going to solve for final velocity, you would divide by mass on both sides. And to solve for final velocity, you would add initial velocity to both sides. So we end up with impulse over mass plus initial velocity is your final velocity. And when you do all of that with the numbers given, you get 10 newton seconds over 1 kilogram plus an initial velocity of 50 is equal to 60 meters per second is what you would get for that particular problem, which is number 21. That's all I have time for tonight. As far as the key goes, if you have any specific questions about the final, you can always email me or come see me in the morning. Good luck on all your finals.